Hello, everyone. Welcome back
Hello,
to another.
hello.
Welcome back to another Mike and Max stream.
Getting used to it.
Yeah, really.
Okay. So I've opened up the mod view. If anyone starts to complain, I'll ban everyone. That's fine.
Ban everyone.
Ban everyone, yeah. That's a good start.
So, I think that today's stream is a little bit different than what we do on Wednesdays usually. I don't think we're really going to be doing that much coding. Maybe we'll get a little bit of coding done, but um, the purpose of today's stream is really to discuss. In Discord offline, we've been having discussions about cluster, and ways that we can improve it, ways that we can make the user experience better, make it more accessible to folks who want to use it, and also just generally improve the API and kind of enable more things to be accomplished with the API. So we figured instead of chatting about it in Discord offline, we might as well chat about it in public and let you all hear what we're talking about. Um, and we may be joined in a little while by Mattia as well, who's been kind of the driving force behind Cluster up until now. Um, and yeah, one of the things that we have been focusing on recently, for those of you who are maybe not familiar with Cluster, um, it is a cluster sharding framework that has been built into effect. Originally, I think it started off as a direct port of shardcake, right, Mike?
Yeah, it kind of started off as a direct port, but then it was extended to support more reliable forms of communication. I think Shardcake only took care of the sharding part. Was really more of a sort of a computation framework instead of it being a framework that allowed for durable computing to execute and other stuff. So Mattia initially took the design from Shardcake, and then with a few iteration loops, we sort of reinvented part of the internals, and now we are in a phase where we are starting to consolidate on the ideas. We already have some alphas out. Some people already tried it out. We have the first learnings to integrate, and given that it's quite a complex project, we thought a public synchronization every sort of week or bi-weekly would be helpful to sort of get aligned and make sure we make a great thing.
Hey, Mattia, welcome.
Hello, everyone. Sorry, today I'll be kind of joining in, join out, join out. But yeah,
No
No worries.
worries.
Totally
lot of
fine.
things going on.
No worries, no worries. Just happy that you're here. So we were just kind of talking about, kind of catching everyone up on what we've been talking about offline.
Mhm.
So recently, our focus has been kind of on the creation of entities within Cluster. Basically, like how does a developer who wants to start creating entities to be able to register into a cluster, how does that look like? How can we improve the current API? How can we enable more things without adding a whole ton of verbosity? Um, and so we've been really talking about, the what happens when you send a message to an entity, either from a client or from another entity. What should the process look like? What happens when that
Mhm.
message is received by an entity? And then how does the developer control the behavior
Of
that
the flow.
happens when that message actually gets processed? So we've been slowly, I think, zeroing in on a pretty nice API idea. Nothing's really been like implemented quite yet, but we've been slowly kind of like zeroing in on what we want. Um, and it seems totally possible. It's just that I think that now we're trying to kind of like finalize some of those decisions and maybe like sketch out like some diagrams about what we want this to look like and whatever. Um, So yeah, um, I don't know if you guys want to, but I was talking to Mike, and I personally think it would be helpful if we diagram some of this stuff
Yeah,
out so that we
yeah.
can like have a visual representation of the things we've been talking about, even if it doesn't cover everything. It'll at
May-
least
Maybe we can start diagramming out what is the current flow in the current alpha we have, and then try to see how that maps out to what we want. If there are some parts in common, if we need where we need to change, basically ensuring what is the current state of the flow, and then seeking out what we want the flow to be.
yeah, I think that sounds good. I'm gonna start out using TL draw. Yeah, so maybe we can walk through kind of what the current process is, and like Mattia said, and maybe we can do it from the perspective of like, let's say the developers like registered an entity with the cluster, and there's a client that's sending a message to that entity, and maybe we
Mm.
can kind of walk through what the current process is. Um,
Maybe
so
we can start by we say that we have two different systems. So can maybe start out by doing two different logics that actually represent the two different systems involved in the communication. Okay, and inside those two systems, those are what's called the pod. Those are basically the application behavior runner, let's say. A pod basically is an application server that runs your behaviors. You can run many kind of different behaviors and can host many kind of entities.
we've got an application server.
Yeah.
This application server is the
Let's call that
equivalent.
pod B. Let's call that pod B.
And just again to help those who are maybe not familiar with cluster parlance yet, the cluster term for something like this is a pod. Pod can host multiple shards with multiple entities per shard. And so let's duplicate this.
Basically, a pod is, in simple words, what maps to something like a Kubernetes pod, which is a JavaScript process in a sense. Correct me if I'm wrong.
Yeah, I think that makes sense.
Hmm.
A pod can host multiple containers, just like in cluster, a pod can host multiple entities. What did you want pod A to represent in this case, Mattia?
Uh, both are application servers. They are both application servers. They are in the simplest solution. You will have only one pod. The simplest solution. In the most complex solution, they have thousands of pods. The key thing is that may have multiple pods, but the code they run is basically identical. Okay, you can have one or more many identical copies of your application servers. Okay.
Okay. And
And
then,
pods get assigned a number of shards.
Exactly.
right, so like maybe we can just represent that really quickly with like a shard one, right? Oops. No.
Maybe I'd say maybe that's something that um, a shard is something that gets assigned to a pod. Okay, so basically the thing is that we said before that pods run entities. Okay, and entities have each one a unique ID that represents that entity. Okay,
Right.
and the thing is that if the shard manager has to um, know where each single entity lives, that can be very computational heavy because you can have thousands of entities in your system. Okay. So what the system does is something clever is instead of knowing exactly where each single entity lives, the cluster will basically group many entities into a group that's called a shard. And basically a shard is a group of entities. Okay. So the most simple example I could give is let's say that we have a group of people, okay, and we need to divide the people. what can be the way to divide those people? We could say, for example, that based on the first letter of their name, we split up those people in groups. So instead of having a large group of people of 20 people, we have smaller groups that are easier to manage. And that's basically what a shard is. It's a group that represent a list of entities, but is simpler to manage from the cluster side.
And most importantly, the assignment between a shard and a pod is managed by the shard manager. So there is a process which basically monitors all the shards, all the pods that come up, and
Exactly.
handles the rebalancing.
Exactly.
And instead, an entity never changes the shard assignment. An entity is assigned to a shard in a static manner. So let's say, for example, we have, I don't know,
The implement-
1024 shards. Each entity will have an ID. We hash the ID. We
exactly.
divide. We take the modulo 1024, and that gives a single number, and that entity is assigned to that shard. In this way, any participant of the cluster or any even external actor to the system can always know, okay, to contact this entity, I have to figure where this shard is. So they basically subscribe to the live assignments for the shards, and they know where all the shards are. And based on the relationship entity to shard, they know which pod to communicate to.
Exactly. The
Much.
implementation you described is the implementation you described for a way to determine the shard is exactly the one that we are using. Basically, hashing the ID of the entity and modulo that to the max number of shards you configure in the system to have, and that's basically a number that you can deterministically that have just knowing the entity ID and the configuration of the max amount of shards you wanted to have in the system.
Yeah, so I sketched out here just like exactly what we were talking about, to so everybody can follow along. We've got our application server or our pod, our first pod, pod A, which has n shards on it. We can have anywhere from one to many shards on the pod, and then each shard can have many entities registered within it. So
Yeah.
we've got, and
I
these entities, maybe the ID here is not not tech, it, if I
It could
understand
be, for
correct.
example, user hash one, user pound one, or to do pound two. Those are they are not constrained to be the same kind of entity. Okay,
Right.
they can be different kind of entities. Exactly.
Right. So we might have like these kinds of entities all the way out to n, and then
And
maybe
the same
down here
goes,
we have
yeah, user
to
two,
do
and
to do number two, user two, all the way out to n.
exactly,
Um, and then this kind of like structure, if I understand correctly, is replicated across basically every pod we have. So every
exactly,
pod can have many shards, and every shard can have many entities. And for the reasons that you described, that makes addressing an entity reasonably efficient within the cluster.
exactly, exactly. And as I said, all servers are basically a mirror, so we can just basically to take the description we just drew and copy that to make that server pod B, because basically inside we have the same kind of structure.
Yeah, with the
Um,
difference that maybe on pod B
Yeah, exactly.
you don't have the same cards as pod A.
Yeah, exactly. You have shard two that has user number three or whatever. Yeah,
um, well, maybe instead of copying this over, we can start like describing. Maybe we could like zoom in on like
yeah.
when when a message actually gets sent to one of these entities, what actually happens.
Okay,
So I think in the current flow, right? Let's assume that we send a message. Let's actually zoom in on one of these. Um, but let's say we zoom in on this particular entity, right? Um, if we have our user one entity, right? So let's describe like what actually happens in the current flow when user one receives a message. Um,
Well, we first have to describe what happens when you send a message,
Exactly.
probably.
Exactly. Sorry, I was muted. I was saying exactly the same thing. When you want to describe it first, what happens when you want to send a message from one entity to another?
okay, so
Okay. Okay.
And I mean, doesn't even need to be an entity to another. Can be an
Yeah.
external
External system,
process.
whatever. Yeah.
why don't we do that? Why don't we do like an external client sending a message to the user entity, for example?
Yeah, because that's exactly the same, basically.
So this
Okay. So
is user, and this is an external. If I can click this, external sending some message.
okay. User one actually is inside the shard one because
Right. So there would be like maybe like a dotted line over here or something
yeah,
like that. That
yeah,
you
something
could
that,
draw.
that describes that. Okay, that lives inside of. So the first thing that we need to acknowledge is that in order to be able to message with an entity, you first need to know which is the messaging contract. So you need to have the schema of the messages that that entity supports. Uh, and why we need that? We need that because the first step is indeed serialize the message that the external client is trying to send in something that can go over the wire and can be received by the user one eventually. So first thing we need to serialize the message, okay? And now we have something that can go over the wire. So now the question becomes where it should go, because as Mike pointed out, we may have different pods, and we need first to determine which is the pod that is currently running the application behavior of the user number one. Okay, it can be on pod one, pod B, pod whatever. So in order to do that, the current implementation basically relies on having a local cache of the last assignments of the shards in the system that happened. So basically, each client has a cache where it knows its shard ID in which pod is running. It may not be the actual pod that is running that, but is at least a cache, something that eventually maybe can be expired, maybe the entity is not there, but and then when it tries to send a message and detects that the entity is not actually there, it will try to refresh that cache. But
It's for
basically,
the shard address, not for the entity address.
sorry, sorry, not the entity address. Yeah,
Here
from the
we
shard
should
ID.
say if you address the wrong pod
Yeah,
and the pod realizes that the entity is not present, the pod is gonna have a different cache and it's
it,
gonna forward
yeah,
the
exactly.
message to the correct endpoint.
Yeah,
So it might take a few hops
yeah.
in a very uh, in a very critical case, but at the end we figured the right pod where the entity is hosted.
Yeah, that could be one way of doing that. The way of doing that right now that shardcake takes is basically saying the client, please ask the shard manager for the correct mapping. Then
That's the way.
that's instead of doing many hops, it just
But
tell the client,
the external client does not have
yeah,
access to shard manager. So for
exactly.
external client, this is not possible.
Yeah, exactly, exactly. That's one limitation indeed. So that's something that maybe we can address and try to change. And so that's the first thing that we need to appoint that maybe it should be changed. And then now let's say that the cache is correct and the shard ID resolves to a pod address. And now the client will basically send that serialized message to the pod just result. Okay. So let's say that you solve that the entity user one is living on pod A and then it sends the serialized message to the pod A. Now we have the message received by the pod A, but then the pod A, as we mentioned before, hosts many kind of different entities. So we need to basically route the message from the incoming external interface of the pod A to the actual entity that is processing the message, okay? Because as we can see from here, pod A have many thousands of entities.
So the pod A here receives the message. I'm going to make this bigger. Put the user down here maybe for a second. So at the moment, the pod has received the message, right? Pod.
Exactly. The pod received the message.
Okay.
And now you need to figure out, based on the message, which entities basically will handle that message, okay? And that can be user one or to do one or whichever entity is living right now into the pod A.
Okay.
Okay. And now that we have the message will basically go into the mailbox of the specified entity. Okay. But before doing that, we need to ensure that the mailbox for that entity is constructed because user number one may not be alive. Okay.
Is this the current flow? The entities currently have a mailbox?
Right now it doesn't have a proper mailbox. It have that kind of offer function, but the thing is mostly the same because the offer function that is constructed when the entity is alive is kind of the same of the function of the mailbox to put in messages. The thing
Right.
will be mostly the same. It changes the shape of the data behind, but the concept is the same. When you start up an entity, you get back a function that will be used to put in messages into the queue.
So the pod would resolve the entity associated with the message.
Yeah.
Would it would construct the entity if it's not present, right?
Exactly. And we'll construct the entity. Yeah.
To
If
create it. And then I guess we can just say place message. I'm gonna put mailbox in quotes because technically we don't actually have a mailbox yet. In the current iteration of cluster, there's not really a concept of a mailbox yet. This is something we're changing.
Instead we have just a function that when you construct an entity, you get back a function that you should call when you want to basically give message to the entities.
Right. So this is kind of like the offer function.
Exactly.
And basically placing the message into the entity's mailbox in this case will immediately cause the entity to start processing that message, right? Because we're telling it.
Not really. It depends on, right now, it depends on how it's implemented the behavior, because calling that offer may just be something like putting into an in-memory queue the message, and there is an active fiber that is draining message into the queue. So the act of putting the message into the queue is not the same of processing it. Maybe if you want to, you can process it. That in the current implementation, you can also process it in the moment you receive it, because in the current implementation, you are basically providing just that offer function without a proper mailbox. So in the current implementation, you can theoretically process the message immediately without spinning up a queue or whatever. But what we are trying to migrate towards will have indeed a mailbox.
Right. Okay. So in theory, this is like that's like a user land detail. I mean, it will be a
Yeah,
user land detail as well, like how fast I guess messages get processed in the new implementation we're thinking about. But I think it's more easy to control.
yeah. It's kind of more easy because you are basically enforcing to have some kind of mailbox, which is a good thing in the end.
Okay, so um, we put the message. We've offered the message. Maybe I'll just say that instead.
Yeah, offer. Yeah,
Offer offer the message to the entity, and then at that point, the message becomes the responsibility of the entity.
yeah, exactly. That of that offer function right now is also the point of connection that is used from the external client to get back the result of the message when it gets processed. Because that offer function has a signature that takes in the message and returns back basically a union that is basically either I just acknowledge that you give me the message, so I'll say, okay, I've seen your message, that's it, or this is the result of processing that message.
Right.
And why we need that? We need that because when we send a message from an external client to an entity, we can have two kinds of send, basically. We can send and don't care whenever the message will be processed.
Which I guess in traditional actor parlance would be like an
Fire and forget.
ask.
No,
Yeah, or
if I don't care, it's a fire and forget. I just want to tell the message and I don't care about the result. Or
right.
if you care about the result, that's an ask. And you are basically, what will happen behind the scene is that the first offer would maybe response with just acknowledged, and then the client gets back the acknowledged, and the client will say, okay, I will try again because I want to get back the results. So the client will try again and again to call that offer function until it gets back a message state of process.
So the entity's behavior, process the message, and return the either an acknowledgement or the result of. Now, in the current implementation, if I understand correctly, the uh, this when the behavior is triggered and the result is the message is done being processed, the client, like let's assume the client did a like the equivalent of a not fire and forget and ask, right?
Mhm.
Um, the client, if an acknowledgement is returned but a result is not, the client actually has to do the retrying in that case
Yeah,
in the current implementation.
yeah.
And I guess we're trying to change that a little bit with the new implementation, right? Where
I'm not sure if we are actually changing that because
Well, we should, because this is
yeah,
completely inefficient.
yeah, it's inefficient, but what we are basically trying to implement is something that um, basically, if the client asks, the most efficient way would be to let the client request to hang until it gets processed, right? That would be the
So
most
TTP
performant.
return partial responses. You can return an act straight away and then return something else later.
Yeah, exactly.
But the issue would be if the message takes longer than what the HTTP channel uh,
Could handle.
could handle. But on the other side, if we are saying that all the messages are persisted, then the communication channel is actually the database.
Yeah.
So we would just kind of listen to the database changes.
And that is basically the same as saying instead of retrying sending in the transport layer, it's basically something like I fire the request the first time and I get back something like I need a retry later HTTP response. And then instead of actually retrying on a fixed schedule, I listen for database changes, and I retry when I see the database changes. That could be another way of doing that, acknowledging basically the same result. We are basically using the database as a shared channel between all the cluster to notify when we
Yeah,
have
and to be
new
fair, you could
notifications.
even have a message. You could even have a message broker in between.
Yeah,
You could
yeah,
implement everything on top of Kafka or
or whatever that notifies you
whatever
whenever you
else.
want.
Doesn't really matter.
Yeah, yeah. That's something that, in my opinion, is more on the transport layer than in the actual assumption we should make. We could say that it's up to the transport layer to retry the sending, and that could be the dumbest one, like the one we have currently of retrying on an exponential schedule, for example, or some smarter one like the one we described using a database for as a trigger for retrying.
Oh, but I agree that the in that case the client should figure out how it wants to wait for a message to be processed. Like the trans
In the end, the client will just pull the send and get state implementation of the transport service. And then the transport service in that implementation could do whatever. Could retry, could wait, listen for database changes, or whatever. You could also have something like sending messages over HTTP, but having trigger for notification on a completely different system, for example, whatever madness you want, if we leave that responsibility to the basically the transport context service.
makes sense.
So we are basically operating on the assumption that um, if the context service sending at state knows what states he wants to return into, so it's fine. It's basically an union saying, I am fine returning in acknowledged, I'm fine in returning in processed, I'm fine returning. And basically, then the transport layer will retry until the, the response gets in that state.
Yeah, I think that makes sense. Maybe we can talk about a little bit about what we don't like about the current implementation, and then we can start maybe hashing through some of the things we've been chatting about for the like updated implementation, like things that we've been thinking about. So, um, in this current implementation, um, we're very limited in the on the behavior side, some to some degree, on a number of different things. For example, the way that the behaviors interface is currently implemented, except unless you implement the unless you use the in-memory queue version of a behavior, if you use like just the standard behaviors that cluster exposes without the intermediary queue in between, there's really no way for a behavior to essentially spin up a long running fiber that's just processing messages, right? Like
Well, it's kind of well, it can, to be honest, because the signature is a function that returns a function that takes the message and process it. So the outer
Basically,
function is the lifespan basically of the entity. So you can have
point is
or
currently what the user specifies is sort of a recipient behavior
yeah,
instead of the
the
processing
actual
behavior.
exactly.
What we're thinking of is to separate the mailbox, which would be the default recipient behavior, and have that for every entity, effectively transforming a generic entity into an actor, because actors have mailboxes and they're processes that pull from mailboxes. So basically, we are sort of making it a default, simplifying a little bit what the entity behavior is about, which means that an entity behavior always has a mailbox to pull, and it pulls messages from the mailbox, and we have a little bit more having a standard, we have a little bit more informations
Mm.
on what happens inside. For
We
example,
are
are
basically
there
splitting
non-processed
concerns.
messages? Yes, we
We're
split
basically
concerns.
splitting concerns in order to have a more default behavior. That the implementation we have right now is something very low level that in order to do those kind of behaviors, you need to compose all of those things into only a single process function, basically. But what we are trying to achieve is something like splitting that in different concerns. So the user maybe don't care about one of those concerns, like the recipient behavior, and the user only cares about how the messages are processed.
And
So
it
we
and it
like
becomes
basically that.
much Yeah, and it becomes much easier in the implementation that we've been discussing to do things like um, allowing concurrent processing of messages, like without having to have an intermediary queue in between. If the because the design that we're kind of thinking about is that the user defined behavior for an entity would essentially receive a read only side of the mailbox
Yeah.
where the behavior can pull as many messages as it can like theoretically handle. And the kind of similar to like a request resolver for those of you who might be familiar with request resolvers in effect. um, the behavior would get access to some functions either from something that we pass in or from the context of that behavior where the messages could be marked as acknowledged or completed. And in doing that, we can enable the functionality of at most once message processing or at least once message processing reasonably, not, I wouldn't say like easily, but like the user can basically by changing where messages are acknowledged or completed within the behavior can essentially have full control over um, that kind of like behavior for message processing. If you acknowledge the message at the beginning, process the message later, or if you acknowledge the message at the end of processing and then complete it, um, like those are the kinds of things we're thinking about. And by adding the mailbox back to an entity, we can kind of like separate those things and
Mm.
enable that kind of functionality. I think Mike, you were also kind of thinking about um, the sort of like a type of behavior, a cron-esque behavior,
Mm.
and maybe you want to talk a little bit about that kind of thing that you were thinking about because it was really interesting. And by switching to this kind of a design, we'd be able to enable things like that.
Yeah, I was kind of trying to stretch the boundaries of what's possible. I've been dealing with those sort of systems for most of my professional career, having started with Akka clustering and so on and so forth. And one tedious thing to implement was always this dynamic cron thing. Let's say that, for example, we have a process that is dependent on some users, and for example, a user says, "Send me an email tomorrow at midnight," or "Send me an email in a year time."
Mm.
Uh, what happens? I send a message to an actor spins up and processes the message, but then the default behavior of an actor is to passivate when the message is processed or received. So if I process the message, the actor goes down. If I don't process the message, the actor times out. How do I actually ensure that this actor keeps running for the time needed to actually end up sending the message? So my thinking was, okay, if we have a mailbox and we send a message like start cron, we can acknowledge that the message has been, uh, well, not even acknowledge, we can just park the message, have it in the mailbox, and decide that the actor is alive for as long as there are non-processed messages in its queue. So let's say that I send a message, the actor receives the message, the cron is started, and the message will only be resolved when the cron is triggered. So when the actor finished its job. then let's say that this actor goes down because I set a cron in a year time, and even if 10 years ago we could have servers that were running for longer than a year, in the new world with container environments, constant updates of software, and so on and so forth, we're pretty sure that there's no process running for longer than a few days. So the entity goes down for any reason in this world, it comes back up. The pod checks, okay, I have in my allocated shards, there are some non-processed messages. So let me start up the actors again, which means the actor starts up, they pull the non-processed messages, and they will see, oh, I have to start a cron. So I'm basically re-getting to the same state as I was before. This is possible because basically I'm separating the sending the message from the actual processing of the message and from the process of acknowledging the message. So the sender only cares that the message has been received, which means it's been placed in the actor's mailbox. It means it reached the destination from where the actor is going to be able to ingest it.
Yep.
So the sender doesn't, it's a fire and forget from the purpose of the sender, or rather, it's a fire and forget where then the sender can pull for the status. But then the sender sort of goes down, goes away, and the actor has these non-processed messages which are kept alive up until the point where they actually are processed. Now, the non-intuitive element here is that this sort of requires assumptions on the transport layer, or rather on the mailbox, because one important element is that actors always see messages in the same order. Because
Yep.
if I start up and see messages in the opposite order, bad things can happen. And the order is it is very important.
If the method behavior is deterministic, the order of the message coming in should be deterministic as well.
Yes, that's the point. Otherwise, we introduce a non-determinism
Yeah.
in the very entry point
Of
of
the
the
system.
actor, which makes all determinism go away.
Yep.
So we need determinism on the order, and to do so, we need some sort of persistence layer where messages are stored in a specific order. And my intuition was that the easiest way is to sort of have a sequence number which is incremented for every message, and a processed flag. So when an actor processes a message, sets the process to true, and then we can have a query that is like, give me all the non-processed messages ordered by the sequence number. So I always get all the message in the same order, even though they may have gaps. Because let's say that first I send a start cron, then I send a completely different message. The second gets processed, the cron only gets processed when the cron triggers. I will see in the second query only the start of the cron and the message number 3. I won't see again the message number 2 as it has been already processed. But the non-processed messages are received in the same order. This might be a slightly confusing because I have a lot
Yeah,
of context in my mind, but
let's sketch it out. Let's keep sketching it out. I was trying to sketch it out as you were talking, um, but I'm basically using your example of sending an email in 1 year, right? This is the message that we're sending to our user one. I don't know. We can call this maybe like email one, right? We have an email entity here that sends emails, maybe. So we're sending a message. This email entity can handle a message that says to send an email after a particular period of time has elapsed. We're sending this email or this message, and eventually it gets makes it to the entity. I'm kind of removing some layers here,
Yeah,
right? The whole getting to the pod and everything, but the message makes it to the entity. So in Mike's model, the client over here really only cares that the message was received
yeah,
by the entity, right? Because the client doesn't need to do anything else with that message once the entity
Doesn't
is
want to
actually
wait for a year.
right. Um, so
maybe I can pull with an exponential backup for a year and ask.
so we do get a response in this
Yeah,
case, right? There is a response sent back to the client,
and the
which
response just says received.
I don't know how to increase layers in TLDraw. It doesn't matter. Uh, the response just says received, right? So here, received.
Just say yes, mom, I received the message.
Oh, arrange. Oh, okay. Well, I tried. Um, so bring to front. Maybe I can send this thing backward. Okay, doesn't matter. Um, the message was received by the client. The message was put into the mailbox. And in Mike's model, if I'm understanding correctly, stop me at any time, Mike. The message then gets sent to the mailbox storage.
I see that. I think that what Mike is saying that upon receiving the message in the mailbox asks immediately the storage to persist the message,
The
and
Right.
mailbox is the storage.
the mailbox because in this chart the Max drew the storage and the mailbox are two different entities, but yeah, they are
But that's the
basically the same.
point.
Yeah, they are basically the same
Well,
component.
I'm just basically designing like there's an external and there's something external
Let's
to
say
your
that
story.
yeah, let's say that that is a database. Okay, let's say a Postgres table. Okay.
Sure.
Okay. So basically, what we are saying that when the mailbox receives the message, the thing that we'll do is try to perform an insert into the database, get back the assigned maybe auto increment ID or whatever that is in the database table. That is a progress sequence number inside that table, and only once the mailbox receives back from the table that sequence will tell back to the entity, okay, I received the message, because the mailbox wants to ensure first that he actually persisted the message. Okay.
Okay.
So if for some reason the database is not responding or whatever, what will happen is that after maybe some kind of timeout, the mailbox will say, okay, I failed storing the message. And the client will say, no problem, I'll try again. And there we will have some kind of retry logic. But that's only for cases where for some reason the storage isn't able to persist messages. It's something that
Okay.
we can maybe decide that that is a defect. That's something that shouldn't happen.
So messages get a sequence number
Yeah.
essentially. So
Let's
Which, by
things.
the way,
now from
cannot be an auto increment.
yeah, I was saying auto increment because it's the simplest thing to understand for anyone. Yeah.
So
Yeah,
just
but
the
the issue is auto increments are vulnerable to
Yeah.
transactionality,
Yeah.
so you
When you
can
have
actually
insert,
witness.
you know,
so we got messages in the database. Some of the things that they're going to have are a sequence number. They're going to have a processed maybe field or something like, or maybe a state. Doesn't matter, but some notion of like, was this thing actually processed?
maybe
Um,
before then processed. Yeah. Let's say sorry. Let's just stuck with processed for now. Let's
yeah, I'm not going to enumerate all the fields that might be in this like message table, but
no.
just kind of like getting an
Saying what
idea of
yeah,
Processed, acknowledged.
yeah, exactly.
yeah. So acknowledged. Like this
The
one.
response, if it's there.
Yeah.
Sure. Um, okay. So now let's like keep operating under the assumption that the client sent this message, this email, send an email in a year message. We've successfully inserted it into our mailbox persistence, which is in this case is some database running somewhere. And we've communicated back to the client, okay, we've received your message, blah, 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 blah. Now what? Now what happens?
Now what happens is that now we have communicated basically that we have received the message and persisted it to the client. Okay. So now based on what the client wants to do, we basically have different routes. Okay. If the client just wants to tell and doesn't care about the result, for the client, that's it. Okay. The client.
In this process, the client is done.
Okay. In this process, the client is done.
Okay.
Nothing else. Now, the thing is that now we actually have to consume that message that we have put into the mailbox. Okay. So when we created the entity, okay, that this email one entity, okay, we together with creating a mailbox, okay, we also spawn up basically a fiber, a process, okay, that consumes messages from the queue, the mailbox. Okay. So
Okay.
after we have inserted the message into the mailbox, what will happen is basically that on maybe a separate fiber, that message will be taken. Okay. And by taken,
This is the actual behavior of the entity we're talking
yeah,
about now, right?
yeah,
This is the user implemented behavior.
yeah. So
Okay.
we are basically speaking on how the user implemented behavior will take the message from the mailbox. So this is the part that is concerned by the user, is written by the user.
I'll use the European behavior.
Okay. Okay. And now basically what we will do is we'll take messages from the mailbox. And when it takes messages from the mailbox, in some way, the way we were thinking altogether is just by using the sequence number we mentioned before. In some way, once a message is taken, that's it. It will be not be offered again into the mailbox. Okay. For this process, for this fiber being alive. Okay. So once you take, you for this process, that's it. You have taken. Okay. You've taken the message. And in that way, this process can basically continue to take from the mailbox and just receive new message as they arrive in. But what we,
So
yeah,
so in Mike's model, right? So this user implemented behavior, let's say this thing is going to be a this in this case, like it could be anything, right? But in this case, we have a long running fiber that is continuously pulling messages, right,
yeah,
from the mailbox.
yeah,
Let's say that eventually we arrive at the, send email in a year message, right?
mhm,
But it's not been 1 year yet.
okay.
In Mike's model, what happens here?
I think that in Mike's model, what happens here is that you just take the message and you don't do anything. Or maybe you start the
You
timer
take the message and you
and you start
start a
the
set
timer.
timeout.
Yeah, exactly. You don't
Well,
do anything with the message.
actually, you check current time
Yeah, exactly.
and you start a timeout.
Yeah.
You need to check current time because it is possible that failure has occurred. So if now is already later than
The expected
the expected time, it means the timer should have fired.
Basically,
But
you do the time difference. If it's negative, you start the timer immediately. If it's positive, you wait for that amount of time.
And so
yes,
this is like a user land thing. If
Exactly. Exactly.
right, okay.
But
yeah,
in
there's
the
nothing custom.
yeah, there's nothing.
That's the point. The protocol allows for this type of stuff.
Yeah, the thing is that the user just takes the message and starts the timer. Okay, but the user doesn't acknowledge the message until the timer is expired. If I understood correctly the
Yeah,
model that might.
when we send the email,
Yeah, we acknowledge the message.
you told me to send an email in a year. When I send the email, I'm responding with email sent,
Yeah, exactly.
or with,
I just
email
acknowledge.
address did not exist. The word that has
And
exploded 3 times. I have a failure.
and in a word, okay, so I think that I'm tracking pretty well. In when the email is actually sent, right? So let's just quickly let me put that in here.
We have basically two cases. Maybe it's too early and we just start a timer, or the timer basically is expiring or is just expired. And in that case, what we do is perform the work of sending an email and acknowledge the message.
Right. So here, a timer is started based on current time, right?
Yeah,
Or timer is started, and we look at current time.
exactly.
Sometime later, we arrive back at our
Um,
uh, we arrive at our timeout,
yeah, it's
right?
the 29th of July of 2026.
Right. So now um the the message is completed 1 year later,
Yep.
right? Um, so in this case, when the message is actually completed, the in my mind, this is either going to be something that's like the user actually has to call, right? So the user has to indicate, hey, this message is now completed to the system, right? Because if the
Exactly.
user never completes the message, the system can never know the message was actually finished. So you
Exactly.
could imagine something similar to like a request resolver where you call like request.complete. You could, there's something similar here where maybe there's something in the context of behaviors that allows you to just complete messages.
Maybe if you
Or
receive the mailbox object, you can just do mailbox.complete and pass in the envelope you are.
right, exactly. That would be another way is like there's an object that the behavior return receives that either is like represents the entity or the mailbox or whatever, and allows you to complete the message. And so transparently that writes back to the kind of database here.
Yeah, to updating that flag of acknowledged to true, saying, okay, I acknowledge or even processed that message.
Right. So now our message is processed. And that's transparent to the user. So can I do a dotted arrow? I feel like I'm asking a lot right now. Um, but whatever. You get the idea. There's some sort of write happening back
Yeah,
here transparent to the database. Maybe we can like indicate that there's like some sort of you know proxy service that the behavior has access to, but the behavior doesn't actually need to know that
yeah,
what it's doing. All the behavior has to concern itself with is either acknowledging or completing a message,
yeah.
and they are different, right? So acknowledge.
The idea was that the behavior could maybe deal just with the mailbox, and the mailbox is as the shape you draw is the thing that is in between the actual persistent storage and what that entity can do with its own mailbox in the storage.
Right. So
So
this arrow is a little bit misleading because it's not necessarily like it's not a direct write because the user is just indicating that a message is completed, but behind the scenes, whatever's been provided to the system as like the mailbox storage is essentially getting updated with the fact that that message is done.
exactly.
And then to Mike's point, when a pod or shard is spun up, part of the like spin up operation, part of like the initialization of a shard or a pod, like part of the initialization has to include checking the database.
Spawning up basically all the entities that have unacknowledged, not acknowledged messages in their mailbox.
Right,
We
right,
need
right,
to basically know uh, from the mailbox storage, we need basically to know the list of all the entity types and IDs that have something for that shard ID that is not acknowledged.
right. Mike, when we were chatting in Discord, you had mentioned the concept of like a last scene. Uh, a last seen kind of cursor that's only in memory.
Yeah, that is the thing, that when you take one message from the mailbox, you will not take that message again when you take again, because let's imagine again that you have that database table but taking the mailbox storage. Okay, when you spawn up the behavior, okay, you start from zero. Okay, and the take operation will just say select top 10 messages from a table where sequence is greater than zero. Okay, and they have not been acknowledged. Okay, and so basically on the first time you run that, you start from zero. Okay, and you will get
Mhm.
message one, message two, three, four, five, six, seven, eight, nine, 10. Okay, so let's say that maybe message number seven, okay, is
Is
taken.
one of these like long running ones.
Exactly, exactly. So you just take it, but you don't acknowledge it. Okay. So it doesn't have the acknowledged flag set in the table. So if you imagine shutting down the process and starting it again, okay, when you perform that select top 10 messages from where
Right.
acknowledge is false and last seen is greater than zero, you won't get back one, two, three, four, five. You start with 7 and then 11, 12, 13, etc. Okay, because the other ones now have been acknowledged by the previous execution. Okay,
Interesting. Yeah, yeah, yeah.
okay,
That makes perfect sense. Yeah.
okay.
So the and last scene only exists in memory
Yeah,
because
only
it's
exists in memory. Yeah, basically, what I was also thinking is that last scene is basically a cursor for the operation of taking messages from the mailbox storage. Okay, you start by not providing a cursor. Okay, and then when you actually perform a successfully take operation, you get back the list of messages and the cursor to use to proceed with the next take. Okay.
and so the idea is that like the user could actually this could actually be exposed to the user so they can from the behavior side they could actually control.
We can do either. We can have that exposed just in the implementation of the actual storage, in the trait of the storage,
Mhm.
and basically use that as a cursor, as something to let the user pass state between the requests, basically, or and just explicitly provide that there and hide that parameter in the actual mailbox that is used by the actual behavior provided by the user. So the behavior by the user won't see that cursor, will just start taking, and that cursor is managed in memory by the effect cluster. Okay,
Mhm.
or we can allow the user to explicitly provide that. And that would be, like I said before, that when you take, you get back basically the tuple of new messages and the cursor to continue pulling from. But I
Mm.
think that maybe we can start by hiding that. And if we see a use case that maybe could make sense providing that cursor ability to the user, maybe we can expose that later, I think. What do
Yeah.
you think?
No, I think that makes sense because exposing that to the user starts to introduce complexity that and we haven't even figured out the like basics yet,
Yeah,
like of the implementation of this. So I feel like we can start by hiding it,
yeah.
and it's
We should provide
always
that on the mailbox storage trait. I call that the trait that has only the responsibility of communicating with the actual persistent, and we could
right.
expose that because that is one point that the user can pick up messages and return some state that will get passed in again on next request. So it's something that the user can customize on its own mailbox storage persistent trait, because who knows, maybe instead of using a global sequence number, maybe you have some database that is append only and uses UUID v7 or whatever as a primary key, and whatever you want, you use that UUID v7 as a cursor saying get all the messages where d is greater or equal than blah blah.
Um, and uh, Yeah, I think that makes sense. I think we can start with not exposing this, deal with it in the mailbox storage for now, and then
And also one further comment, the query that I was sort of proposing is an idealized query, because obviously we cannot have every entity directly hitting the database with queries. Because let's say you have a million entities,
Yeah,
it's gonna be slightly problematic to have a
yeah,
million processes connect to a Postgres instance where every connection is
yeah,
four
yeah,
megabytes of memory. So what is actually connected to the database is the pod,
yeah.
which does a single query for all of the entities
And
and
then,
handles this filtering internally.
yeah,
So
yeah, I feel
uh,
like the mailbox.
potentially the connection is one, and it publishes on maybe
could be one.
a hub. It publishes events into a hub, and then it take filters events from that hub, only entities that it cares about. Yeah.
I think that the mailbox, although we represent it as entity specific, it could in theory be a pod mailbox that handles messages for all of the.
Maybe what I was thinking is that we need to distinguish. We have the mailbox read side that is one per entity, okay, because it needs to take only messages for those entities, etc. And we have the mailbox storage implementation, okay. And that mailbox storage implementation, I think, is something that should be injected via the effects context, so that you can inject that per registered entity, or per entire pod, or whatever you want to, because maybe you have some entities that you don't care about persistence, and maybe you are just fine using something in memory, because maybe those entities doesn't perform something that you care too much about, and you are fine with in memory. If you lose messages between restarts, that's fine, that's something you expect. Let's say that you have an entity, for example, that publishes events or something. If you don't publish an event, maybe there are use cases that it's fine, because maybe you will publish again later another message that completely overrides the previous one. So it's fine if you lose one.
Right.
And so I think that that is something that the mailbox storage should come from the context, and is something that is required in the phase of registering an entity into the cluster. Okay, so
Yeah, it makes sense.
it's actually the context that will be provided to the mailbox.
The last thing I wanted to touch on related to all of the discussion we were having in Discord was something else that Mike had mentioned, which was the concept of an entity having local state independent of like storage. And I wanted to know if Mike, maybe you could expand upon like the use case you were thinking of for entity state specifically that's like an in-memory kind of state.
So here actually the pretty much the only state that I see important to be tracked is if the entities should stay alive even without messages. The the use case was along the lines of the email thing. If we wanted to straight up acknowledge the message received instead of re-getting the message at any point in time, and in that case the the entity would be shut it down, and or rather it would not be restarted when a pod comes back alive. So if instead there is a flag which says, okay, I need to stay alive at least for a year or two, or simply I need to stay alive, I explicitly tell when the entity can be passivated, and it would not be a problem. And in this case, we imagine that the entity has access to, for example, another persistent storage where the entity itself stores the number of triggers that it has to send. For example, I'd send an email in a year, send an email in 2 years, send an email in 5 months, or whatever. Instead of reprocessing all the messages, I could store those triggers in somewhere else and just tell the entity to keep being alive. That's one. That's sort of another possible design, and
Would it be
not sure.
possible to have that sort of like design, not necessarily exactly that, but like just thinking in terms of things that the user might want to control, right? So user probably wants to be able to control the behavior of the entity. I mean, definitely wants to control the behavior, but also might want to control lifetime behavior for the entity. So maybe we could, because I see this, um, like this current model could support the whole like keeping an entity alive forever if we allow the user to pass in when they're registering an entity like a particular lifetime behavior as well, like entity.never die or something like that, or never.
Yeah, but on the
You know what I
on
mean?
the other side, this behavior I was referencing to is more dynamic.
Mm.
If there are no crons alive, the entity can be passivated.
It's something more like some
It's
kind of
not that the entity stays
no,
alive forever.
no. It's something
It
like
stays alive while something has to be done.
yeah, it's something more like a schedule behavior, something like I should be alive or die within this schedule. Something like as you described, maybe I would want, for example, maybe the entity to shut down now, but somehow ensures that it goes back alive in within minutes, because maybe for now the system, as you described it, maybe you have a trigger that triggers in 1 year. Keeping the entity with the fiber spawn up for an year maybe is not a bad thing. Maybe if we detect in the entity behavior that the closest message will be sent in a year, maybe we can by default shut down the entity behavior and tell somehow the system, remember to spawn up me again within, and I'll tell you within maybe 6 months. Or maybe the system will spawn me up again when I receive a new message, and then I'll tell, okay, I want you to shut down now, and then again wait for 6 months. Or I don't care about that 6 months I said before. I want to be alive now and keep being alive now. So maybe something we are saying is, instead of reasoning it of um, how the entity should remain alive, maybe we should work on the assumption that by default, the entity is spawn up every time a message is received, and we could provide the ability somehow to the mailbox to tell, hey, this message, queue it for whatever. And then it's up to the mailbox storage implementation with a stream or whatever, telling me which entities have messages that triggered because that timer expired. I'm trying to toss in some ideas.
I mean, I think the feature that Mike's suggesting is maybe one that could be like an addition to the base implementation. I think like what we have now is already pretty robust for message processing, and that the ability to control the lifetime of the entity could be an addition to like kind of like an MVP that we're working up towards. But what I do think is, um, I think that as a user, there may be cases where, independent of like, oh, I have triggers to process or I don't have triggers to process, as a user, I could see situations where you may want to control the lifetime of the entity globally, right? Like Mattia was mentioning, on a schedule or something like that. Like the entity should remain alive for this period of time or whatever, like a forever, or like a
But
duration that the entity should remain alive if there are no messages to be processed.
I
What
think
I
that
see is sorry. What I see is kind of a lifetime hint,
yeah, exactly.
which
A
is like
schedule.
from the behavior. It's not a schedule. A schedule, in effect, has clear
Yeah,
specific meaning, and
not the
it's not.
not the FX schedule. I meant a schedule meaning you should wake up at this time, and then maybe you could shut
Yeah,
down
or
whatever.
rather the behavior should say, okay, I wish to be alive at this point in time,
Exactly.
or I wish to be alive at
In
every point in time,
exactly
or I have to, please keep me alive at least once
ten
per
minutes.
month,
Yeah,
once per year, whatever.
yeah,
But I do think that this can be staggered on top of, like,
Yeah,
we don't have to do everything
in one
at
batch.
once. It's sort of independent from the messaging behavior. But I do agree with both levels of flexibility. You could specify when you register an entity that when created has to stay alive forever, unless maybe explicitly destroyed. I don't even know what that would mean. But the global thing could be of importance. The local refinements could also be of importance, but I think the most important thing is, if there are non-processed messages, the entity has to be alive. That's the easiest.
Yeah,
That's the easiest of the lifetime things, and this already allows stuff like I can be alive for whenever I want from the behavior, because the behavior is free to post to themselves, to post to itself a message which will never be processed.
yeah,
So, like,
exactly.
if I want to stay
yeah,
alive up until
like a
this point,
like a
I can
ping
send
pong
myself
message
a
almost,
message.
like a
Yeah,
keep
I can
alive
send
message.
myself a message and not acknowledge that message.
Yeah,
So
Right.
it's only more tedious and less and less structured. So
yeah,
we don't have a standard way of doing it, but the flexibility with a mailbox and with different moments of acknowledging, already allows for these types of scenarios. So I would start there and eventually mount things on
Yeah.
top.
yeah,
I think the messaging behavior is where we can, like, we already have a pretty robust, I think, I mean, I'll use robust in quotes. We've discussed this at length, and so I think the messaging is where we should start, and then we can always layer on top the lifetime behavior, like Mike was saying. So,
yeah,
um, but yeah, I think this is good. I feel like the diagrams can certainly be improved, and I will improve these probably with some other type of diagram or whatever. Um, but I already feel like this makes pretty good sense to me and gives us a good starting place to start working on this.
I have to I have to say sorry, but unfortunately now I have to leave because I have an
Yeah,
appointment in 5 minutes. So
no worries.
thanks again everyone for letting me in.
No
Well,
worries, Mattia.
you're
Thank you very
welcome
much.
anytime.
Thank you for joining. Thank you very much.
Thank you. See you everyone.
So, yeah, but I do think we have sort of reached conclusion for at least um, today's argument.
Yeah,
Maybe we can improve the TL draw offline and start to pushing it to the repository at some point in time.
yeah. I think that the diagrams can definitely be improved, but I do agree. I think we've sort of reached a good point of like, okay, now we should probably start prototyping. Like we've discussed and diagrammed enough. I think it's time to like start writing a little bit of code and
Yeah,
maybe
because I'm already thinking in my head how every pod queries the database. I
yeah,
need to see that work.
because in theory you could have quite a few pods as well. And so yeah, I don't know. It'll be
I
interesting to try to
the
figure out.
Look, I've sort of had those problems before, and I'm scared that I already know the solution. Uh, that, of course, is dependent on what database we target, because different databases have different
It's also
things. But
dependent on the size of the cluster, right? And
that's the other point.
how frequently like you're publishing messages. Like if you've got a massive cluster that you're constantly messaging, like yeah, you're going to need probably something a lot more robust than a SQLite database. But if you've got a small cluster, Like you could potentially operate on a small with a much smaller on a much smaller scale.
Well, the issue is not really how many messages you have, but rather how many parties have to be notified of that message.
Right. Right.
Because a single SQLite database or a single Postgres can handle thousands and thousands and thousands of messages per second. That's really not the issue. The issue is having thousand pods querying the database every moment. So that's the more troublesome part. And these either you have a message broker, and then your problems are dispatching between the database and the message broker, which can be solved provided um, that you have some sort of cursor, which you can achieve in different ways. Or if you want to do streaming out of a Postgres, there's really two solutions: one that doesn't scale and the other that scales. The one that doesn't scale is to use PubSub. Uh, Postgres has a publish subscribe feature, and clients can be subscribing to updates, and whenever you update something, you can publish. So you publish a message, and the subscribers then pull upon receival of that message, or they even pull every half a second, every 200 milliseconds, or so. The one that, yeah, Dylan is saying that PG PubSub is a slept on feature. I would agree partially. The only issue is that it's completely inefficient. So the only efficient way of actually achieving streaming out of a Postgres is reading the write ahead log. So basically having your client be part of the replication protocol, which is how any grown up does it, like Supabase and so on and so forth. They all had to migrate to logical decoding and write ahead log injection, which is fine. You get the whole database posted, and you can have like 100. If you have 100 pods or even 1,000 pods, that's still fine. You have a fixed number. It's like one connection per each. You can pool the connections, because write ahead logs can also fan out. So you can have like a PG bouncer where you have the PG bouncer that connects to the to the lead, to the
Mhm.
PG lead, and from the PG bouncer then fan out the same messages to multiple things. Because here the intensive things is not the write, it's really the read.
Right.
So if the read can fan out, so you have cursors and everything else, then it's much easier. But still, it's not a simple problem to solve at a huge scale. It's a quite simple problem to solve at a small scale. And
Well, I think that the somewhat nice thing is that if we build the abstraction for like the mailbox as the mailbox storage, at least for now, we don't have to, we can not like that's a later problem.
yep,
Like it's a if somebody builds a cluster that big with effect cluster, I'd be
yep.
first of all I'd be super happy, but I'd also like that would be a
At
situation.
the time, at the point in time where we have a crazy enough team that is running 1,000 pods cluster on top of effect cluster, I think we can get to a solution. My
Yeah.
point is, I knew what the final how to do it efficiently, but probably we don't want to start. We don't
What the
want to
rate
start there.
what the last boss of the raid is eventually going to be. Yeah.
The last,
The
the last,
the fi-
yeah.
the final boss.
The final boss is logical replication over a Kafka cluster. That's the final boss.
Yeah,
But
well,
the good thing is everything can be pluggable. So the reason I actually wanted uh, effect cluster in the first place was the flexibility. What I didn't like about other systems to run workflows is by default they require a lot of infrastructure regardless of what you want to do. If you're just using cluster for building workflows that back your user registration system, I don't think you're gonna get like a million user registered every 10 minutes. You probably get, if you're lucky, 1,000 users registered every 10 minutes. And that's already way more than many companies have. That can be dealt with a 3 node cluster with ease, like, and without a lot of over engineering on the infrastructure. So that
Right.
should work with a single database, single Postgres, 3 instances, and that's it.
Yeah, I think that what like from an infrastructure perspective, 100% agree. I think from like a UX perspective, what interests me about cluster is like leveraging the stuff that's already in effect, and trying to make like the creation of a cluster reasonably simple, because it's so pluggable. Like enable reasonable defaults, which we currently don't have in cluster. Right now, you actually have to provide every single service, which is kind of labor intensive if you look at some of the examples. But I think like we can get to a really nice experience where you define your protocol in the form of tagged requests from schema, which becomes serializable, and then you register your message protocol with different entities, register those entities with the cluster, and then you spin up as many machines as you need to run your cluster, and that should be like the minimum that you need to do. And then you can always plug in other pieces if they become insufficient, right? So like our
Yeah,
piece,
I mean, I think like there are different layers of abstractions that users can touch. The default user of cluster will actually not even interact with entities themselves. They would probably just use the workflow engine, which is a default entity on top of cluster. So they don't even see these sort of messages and so on and so forth. They just want to write some workflows, and they want to have the cluster that executes the workflows for them.
right?
So that should not require a huge amount of config. Then if you want to use the entities yourself, you're going to have to register the entities, as you pointed out before. But that doesn't mean you should then hook up 100 different types of services to put together, message brokers and so on and so forth. Could use some simple defaults. But if you want to build a high performance cluster, you probably want to customize some of the services for your own infrastructure. For God's sake, if you're running in AWS, you might use SQS. You know, you
Yeah,
might want to use Kinetics and other services to dispatch messages. And that's the point. Flexibility allows you to actually hook in and do your thing. And if you do that, you're probably going to have to provide those 100 different interconnected services, but that's also fine because at that point you want that level of granularity. I
right.
think at the moment we are sort of progressively, we are at the beginning of the simplification process. So if you check the examples, are all hyper complex, having to provide thousands of things, but hopefully we can get to a point where they are actually easy to use.
I think we will. I think we will. As long as we pick reasonable defaults, I think we will. So,
Convention over configuration, to mention a Rails concept.
yeah, exactly. So, cool.
Good. Cool.
Uh,
That's
well,
that's that's a good way of closing the call then.
yeah, thank you everybody for listening in. Hopefully this was interesting. I think
Thank you,
I'll
folks.
have a good rest of your day, and yeah, thanks, Mike.
And see you Wednesday for something else. Cheers, folks.
Cheers.